Broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everyone. We are going to wait a minute or so that everybody can join this webinar, and then we'll get started. All right, well, I think we've already many people joining us, so let's kick it off. Good afternoon again. Welcome to today's webinar, and then thank you for joining us. My name is Alexander Vandenberg, and I'm the Associate Director at the Michael and Susan Dell Center for Healthy Living, and I'm a professor at the UTHealth School of Public Health. And so today's webinar is hosted by the Michael and Susan Dell Center for Healthy Living at the UTHealth School of Public Health in Austin, which is a mouthful. The center's mission is to healthy children in a healthy world. And before we get started, I just wanted to make some housekeeping announcements. This webinar is being recorded and will be archived along with the presentation slides on our website at msdcenter.org. That is msdcenter.org. And if you have any questions during the presentation, please enter those into your in the little chat box, and then we will have time for question and answers at the end of the presentation. And so for today's webinar, we have Dr. Brianna Moore, who is an assistant professor and an environmental epidemiologist at the MSD Dell Center for Healthy Living at the UTHealth School of Public Health. And her research focuses on how early life exposure to environmental chemicals may contribute to childhood growth and neurodevelopment. And a particular focus of her research has been to examine the association between exposure to secondhand smoke and then childhood obesity. So she is obviously uniquely qualified to present today's webinar on the fetal origins of obesity. So I will hand it over to Dr. Moore. And again, if you have any questions, please put those in your chat box and we will address those at the end of her presentation. Thank you.
Thank you, Sandra. Can everyone hear me okay? Sandra, can you hear me?
Yes.
Okay, great. Thank you so much for the introduction, and thank you so much for having me today. I'm really excited. As you mentioned, this is a really interesting area of research for me. It's fetal origins of obesity, and I'm going to be talking about the role of nutrition and the environment. Let me figure out how to go to the next slide. Okay, there we go. So just to kind of build on the introduction that you already gave me, I'm an epidemiologist, which one of the only good things to come from the COVID pandemic is that now everyone knows what I do. I no longer have to explain that anymore. So that's, like I said, one of the only good things to have come out of the pandemic for me. I got my PhD in environmental health with an epidemiology specialization in Colorado State. And then I did my postdoctoral fellowship in epidemiology at the University of Colorado Anschutz Medical Campus. And as Sandra mentioned, my research really looks at how early life exposures influence childhood growth and neurodevelopment. And exposures I look at are tobacco, cannabis, air pollution, and a little bit of nutrition sprinkled throughout. So I want to give a little outline of my talk, just so that you kind of have in mind where we're headed with this. First, I'm going to go briefly over the fetal origins hypothesis, kind of how it came to be and how it's applied. Then I'll talk about the role of nutrition and how that affects the offspring. I'll talk about the role of the environment in fetal life. Then I'll talk a little bit about the intersection of nutrition and the environment, how they work together. Then I'll talk about the translation of findings. And lastly, I'll talk about some kind of future directions, both for my research, but also just broadly in this field. Sorry. Okay, so just to get started with the fetal origins hypothesis, to give a little bit of background, I think most people are pretty familiar that obesity is a growing public health concern. Obesity has been steadily increasing since the 1960s. This figure here, which is from the CDC, shows on the x-axis the years and then on the y-axis is the percentage of adults who are overweight, obese, or extremely obese. And you can see that although overweight has remained steady, obesity has steadily gone up and continues to go up. And at the same time, other cardiometabolic disorders such as diabetes, metabolic syndrome, and cardiovascular disease are also on the rise. So again, this is a really big health concern and just something that should be addressed as early as possible. At the same time, there's been growing interest in the developmental origins of health and disease, or the fetal origins hypothesis. It's called both kind of interchangeably. This is a figure from a really interesting review that looked at the number of publications over the years that were focusing on this fetal origins hypothesis, or the developmental origins of health and disease. And you can see that there's been very steady increase in publications over the years. And I will note that this chart here is only environmental exposure, so it doesn't account for any other exposures such as like nutrition or anything like that in pregnancy. So it's very clear that this is a very growing area of interest and research that also tracks pretty well with the growing trend in obesity rates in the US and globally. So just to give a kind of a definition to what is the fetal origins hypothesis, this is the idea that there are sensitive windows in which environmental stressors such as diet or environmental chemicals can lead to increased susceptibility to adverse health outcomes. And fetal life in particular is a really critical period when exposures can have lasting lifelong effects, which I'll be talking about at length today. This was investigated both in the nutrition field. This fetal origins hypothesis is often credited to David Barker. He was an epidemiologist who I'll go over in the next slide, but he did some really early research in this area. But this was also investigated in the environmental field as well, both in the early 1990s, but retroactively, a lot of research even before then was looking into this, just didn't have a name for it yet until David Barker came along. So in the field of nutrition, David Barker, as I said, he was the first to link low birth weight with coronary heart disease in adults. So this figure has been kind of adapted to illustrate this and to kind of extend this hypothesis. Basically, mothers who ate adequate nutrition had healthy babies that were born at a healthy weight. And so in infancy and childhood, they maintained that healthy weight. And as adults, they also had a healthier weight. Well, in the instance of fetal undernutrition, which a great example of this is the Dutch famine. So mothers who were malnourished during the Dutch famine, for instance, they tended to have low birth weight babies. And those babies would then have not only an increased risk of coronary heart disease, which David Barker had established, but also an increased risk of obesity in adulthood. And the pattern of growth here is really interesting because they started low birth weight, but then if you combine that with poor diet in childhood, that leads to rapid growth in infancy and childhood that then leads to obesity. So the focus really early on was on undernutrition, interestingly, but you can also, much research has been done to show that overnutrition in pregnancy is also linked to an increased risk of obesity. And this is a lot of times attributed to not only just a poor diet poor diet quality in pregnancy, but also increased maternal fuels, so increased glucose and fatty acids circulating within the mother. That leads to an increased risk of obesity in the child. So an early example from environmental health, it's not related to obesity, but I think this is one of the best examples showing this developmental origins or fetal origins hypothesis. And this was a very famous study looking at the daughters of mothers who took DES, which is a synthetic form of estrogen. It's very popular at the time. The girls of those moms had an increased risk of clear cell adenocarcinoma, which is a rare vaginal cancer. And this, like I said, was just a really early example of environmental health influencing the fetal life of the child. But many studies have come along since then linking environmental exposures in pregnancy to birth weight and obesity, as I'll be discussing. So the real importance of looking at birth weight is that the programming of obesity can be evident at birth. So birth weight has long been associated with childhood obesity, specifically macrosomia, or high birth weight, is very closely linked to childhood obesity, increases the risk for by about 30% or more. And the positive note here is that pregnancy might actually be an ideal time to intervene for obesity prevention purposes. Pregnant women are going to the doctor quite a bit, so it might be a good time to talk about some of these exposures that they may be exposed to. And then there's also some evidence that neonatal adiposity, which is actually the child's fat mass, but not birth weight, is influenced by the mother's nutrition. So it's possible that the mother's nutrition is contributing unequally to the child's fat mass and not fat-free mass. And that's a really important finding, but that leads to the question of, does this matter? Does neonatal adiposity or fat mass percentage, does that predict childhood obesity? And we actually did a study very recently looking at neonatal adiposity and childhood obesity. We used a technique called air displacement plasmography. And on the image here, you can see there's a baby in a device called the P-pod. It's non-invasive. The child is put in this chamber that puts air in there, and it basically just can differentiate fat mass from lean mass. And so neonatal adiposity is determined by the P-pod by looking at the proportion of fat mass divided by total mass to give us the percent of fat mass. So in our models, we found that neonatal adiposity did predict childhood BMI levels. So this figure is a growth trajectory, and these trajectories are actually very similar to what you would see with the CDC growth charts, for instance, if you're familiar with those. You'll see that there's a very common pattern where BMI levels go down around 5 years. That's when they're the lowest. But then there's something called the adiposity rebound, which is when the child's weight starts to pick up quite a bit, and their BMI goes up accordingly. So from this figure, you can see that the children who had the highest neonatal adiposity, meaning they had the one standard deviation above the mean, they actually had consistently higher. It was 0.12 kilograms per meter squared throughout childhood, whereas those with the lowest levels had much lower BMI levels throughout early childhood. And then this figure is even more telling, perhaps, because it shows that overweight and obesity was very different according to their adiposity at birth, again, their fat mass percentage at birth. So by the time the children are 5 to 6 years of age, those with the lowest fat mass percentage at birth, only 3% were overweight or obese, whereas those with the highest, about 23% of those were overweight or obese. So this really points to the fact that neonatal adiposity is quite a good indicator of the risk of childhood obesity. And again, I will be using that a lot moving forward in the papers I'm going to be discussing today. But also it's important because if we want to talk about prevention, looking at neonatal adiposity might be a really good target endpoint for some of these pregnancy interventions, because it is more strongly associated with maternal nutrition than birth weight is. So it might be a really good tool that could be used in research or clinical or even intervention purposes. So now I kind of want to give a background. I'll be talking today mostly about data that arises from the Healthy Start study. And this is a very rich, well-characterized cohort that is a tremendous resource. Just to give a little bit of background about this study, the PI of the study, Dr. Donna DeVilia, she started this cohort. It's a pre-birth cohort of 1,400 women who are ethnically diverse. Women were recruited in pregnancy. They had 2 visits in pregnancy where they had many, many measures taken at 17 weeks and 27 weeks. They were invited back, delivery. We actually came to them and measured quite a few things. Then the children and the mothers and children came back for visits at 5 months, 5 years. And then most excitingly, they're coming back now for their 8 to 12 follow-up visits. So they'll be in kind of that pre-adolescent phase right there. And this is part of the ECHO Consortium, which is the Environmental Influences on Childhood Health Outcomes. This is a really tremendous resource because it's pulling together cohorts from all over the country to create, this larger synthetic cohort where you can look at it's a much larger sample size. You have increased power to look at some of these more specific hypotheses. But it's a really great cohort, and as I mentioned, that's where most of the studies today will be arising from, is from this cohort. Some examples of the exposures and outcomes collected. In pregnancy, we collected the mother's height and weight to get her BMI, their gestational weight gain. We also collected urine and blood samples throughout pregnancy, so we're able to look at lipid levels, glucose. We collected diet through dietary recalls, collected multiple dietary recalls. We also got a lot of information about environmental exposures, both through biomarkers and also self-report, but we have many environmental exposures such as perfluoral alkyl substances, which I'll be talking about later, ambient air pollution, and then the mother's tobacco use or exposure. And then the offspring, we have another, a wealth of information there as well. But as I mentioned, we have the body composition measure, which was the PPOD or air displacement plasmography, where it directly measures their fat mass. And then we also have their heights and weights from medical records to look at trajectories. So as I keep saying, it's just a really great resource, and this is just the Healthy Start study, whereas ECHO, again, it's more cohorts, so it has even greater sample size and even more data available. So now I'm going to transition to talking about fetal origins of obesity, talking specifically about the role of nutrition. So overnutrition in pregnancy is very strongly linked with not only birth weight, but childhood obesity and growth-related outcomes. The fetal origins hypothesis suggests that obesity can be transferred from the mother to the offspring. So this has been coined as the transgenerational cycle of obesity. This figure over here shows this cycle being demonstrated, where basically the mother, if she is obese in pregnancy, contribute to fetal overnutrition through, again, increased lipids and glucose in pregnancy. Then once the child is born, if they have overnutrition in childhood, then that might lead to obesity in adolescence. More overnutrition leads to obesity in the adulthood, which then for the women become mothers who have obesity, and then the cycle continues. And as depressing as this might sound or look, this actually is important to think about, because that means that there's multiple time points where the cycle can be broken. You can intervene in pregnancy, you could intervene in early childhood with their nutrition, with the child's diet. You could intervene in adulthood before the woman or father becomes pregnant to, again, just break this cycle. So that's just something to keep in mind, is that this cycle is really informative, not just for research purposes, but also just when to intervene. And in the Healthy Start study, we found that, not surprisingly, pre-pregnancy BMI and also gestational weight gain increases neonatal adiposity, and that these effects were trimester specific, which is pretty interesting, and just something that gets monitored quite a bit in when women go in for visits with their clinician. So it's just something that can be kind of easily tracked and intervened on. Then we have diet quality in pregnancy. This was looked at also in the Healthy Start study. We used the Healthy Eating Index, which is it's pretty consistent with the USDA dietary guidelines. It has 13 components, such as like fruits and vegetables and dairy products. The scores range from 0 to 100, with you can see here the mean in our study was 57. And our research showed that poor diet quality during pregnancy increases neonatal adiposity, but not birth weight. So again, talking earlier about why neonatal adiposity is such an important endpoint, is that it's more strongly related to some of these exposures than birth weight itself. So that could be a really important endpoint for intervention. But I think one of the really important things from this research is that it suggests that nutrition may be just as clinically important as BMI and gestational weight gain. So as I mentioned in the previous slide, a lot of clinicians spend a lot of time talking to pregnant women about their weight gain. But that kind of makes sense, because it's something that the clinician can measure fairly easily. They have more control over that, so to speak, than the mother's diet. But it really points to the fact that maybe we should be spending more time with pregnant women talking about what they're actually eating rather than the weight that they're gaining. I just think that this research kind of points to that maybe it would be better to focus on some different exposures, so to speak, than just gestational weight gain, but really looking at the woman's whole diet and even physical activity. Now I'm going to transition to talking about the role of environmental exposures and how they relate to obesity. So the first is smoking. Up at the top, Sandra mentioned that I do a lot of research with smoking, and smoking has been consistently linked to low birth weight. The first study was in 1972, and since then, researchers have noticed that it's not just active smoking, but it's also mothers being exposed to secondhand smoke in pregnancy. And smoking continues to be a problem, even though smoking rates have gone down. Women still continue to smoke in pregnancy, unfortunately. What's interesting is that after birth, smoking is associated with a rapid catch-up growth. So those low birth weight babies actually grow really fast in infancy, and then that leads to obesity in childhood. But it's not clear right now where that crossover is, where they go from being low birth weight to being at a higher BMI or higher risk for obesity. So in the Healthy Start study, we observed that, not surprisingly, women, offspring born to active smoking mothers experienced low birth weight. They also experienced lower neonatal fat mass and adiposity. But as I mentioned, they experienced rapid catch-up growth. So this figure shows, on the x-axis, it shows the child's age, and on the y-axis, again, it shows body mass index. And you can see from this figure that the dark black line is those who were born to active smoking mothers, and then the dotted line is those who had no exposure. And you can see that the children exposed to smoking were much smaller at birth, but then grew pretty rapidly and even exceeded the growth of the non-exposed children. And our research really added here is that we identified that 1 year is about when that crossover happens. So they're from being too little to too big at around 1 year of age. So again, if you're thinking about intervention or ways to prevent this, looking at that first year of life or pregnancy through the first year of life might be a really important time to intervene. Next, Healthy Start has had several studies looking at the effects of air pollution on the child's birth weight and obesity risk. So previous studies have linked high levels of exposure to traffic-related and ambient air pollution, such as PM 2.5, which is particulate matter. This fine particulate matter is not specific to traffic-related air pollution. It's actually a byproduct of cigarette smoke, but it is linked to traffic-related pollution. Ozone obviously is strongly linked to traffic-related air pollution. It's when VOCs and NOx interact, and the sun actually can make ozone levels quite high in the summer. And both of those have been linked to low birth weight. So in the Healthy Start study, we actually found that there was limited evidence that ozone and PM 2.5 exposures in pregnancy influence birth weight or adiposity. This is inconsistent with previous studies, so that was an interesting finding. But some of the reasons for this might be that there's just much lower concentrations. You know, fortunately in the US, levels of ozone and PM are going down, and metros like Denver and Austin actually have really low levels of these exposures, so that's a good thing. Another thing is that when you look at research in this, when you use the methods that we use, which was just looking at the EPA monitors, so they're not necessarily that close to where the women live, there was not very much variability across the city. So it's actually really hard to look at, there's not much of a gradient to see high and low exposures. So that could be some of the reasons for why we didn't find a whole lot of evidence to support that. Another possibility is that third factor might play a role. This is the first time I'll be mentioning this, but I'll be talking about it more throughout. But it's the idea that these exposures don't act alone. So we found that social factors such as, you know, neighborhood, demographics, the income level, things like that can, when you combine that with these exposures, that actually increases the risk for low birth weight. And then also smoking, when combined with these exposures, can lead to low birth weight and higher growth trajectories. So we actually found that offspring of mothers with high exposure to PM2.5 during the 3rd trimester experienced no difference in birth weight or adiposity among those who smoked. But we found that BMI growth was much more rapid among those who also smoked in pregnancy. So this figure probably looks familiar by now. It shows the age of the child on the x-axis, and the y-axis shows the body mass index. And you can see that when we modeled it, the birth weight was actually very similar across all 3 of these groups, but you can see that among those who had both exposures, so tobacco smoke and PM2.5, that they had a much more rapid BMI trajectory. So just something to think about, that maybe these factors don't actually act alone. They might actually act in combination with other factors, which leads me to this next section, which is the intersection of nutrition and the environment. Again, a lot of times we look at one exposure with one outcome, but we're starting to really realize that it's important to look at how these exposures interact with one another, whether that's a confounding relationship, an interacting relationship, or even a mediating relationship. So one way to think about this is, do nutrition and the environment interact? And an example of this is a paper where we looked at the association between secondhand smoke and infant adiposity, and looked at whether it was modified by exclusive breastfeeding. And we did find that if the infants were breastfed, that there was no change in the adiposity, whereas if they were not breastfed, secondhand smoke was associated with increased adiposity. So this really points to what we already know, which is that breastfeeding is good for the child. It lowers their risk of obesity and adiposity, whereas not breastfeeding is associated with a higher risk for those things. But when you combine it with secondhand smoke, you get an even higher risk for that. So not breastfeeding with secondhand smoke is they interact to create an increased risk for adiposity. So, and other research that I have done in the past, and others have done in the past as well, also kind of points to this nutrition environment interaction where certain dietary nutrients, either in pregnancy or childhood, may actually be protective. And I think this is a really positive aspect of environmental health research. It's a new kind of emerging area of research, because you may not always be able to avoid your exposure, especially with something like air pollution. You may not be able to control your exposure to air pollution, but maybe you can have a little bit more control over your diet or supplement that you're taking. And I think that that's just a really interesting emerging area of this that I hope to see more and more papers about it. And then next, another way to think about this, instead of just thinking about it simply as an interaction, there also could be instances where nutrition mediates some of these environment outcome relationships. So in our Healthy Start, we found that the association between perfluoroalkyl substances, which my image here shows pots and pans. Perfluoroalkyl substances are used to make like Teflon pans. It's also used in a lot of other products like some cleaners and also firefighting foam. But we found that the association between perfluoroalkyl substances and neonatal adiposity was mediated by maternal fasting glucose. So looking at these mediating relationships is also kind of an emerging area of interest, because we're getting at mechanisms and going beyond just what causes obesity, but why it causes, why an environmental exposure might cause or lead to obesity in the offspring. So now I want to kind of transition to talking a little bit about translational findings. A lot of times in my line of research, I've focused a lot on observations. I do a lot of observational research, looking at a lot of exposures and outcomes, but not spending a whole lot of time thinking about how to apply this to clinical practice, to public health. So I think it's really important to start thinking about the translation of some of these findings. And one way to do this is to look for opportunities for intervention. So with nutrition specific to the fetal environment, there's some promising clinical trials looking at the treatment or prevention of gestational diabetes. So educating the women about diet and exercise, Also having teaching women about glucose control, especially if they already have gestational diabetes or if they're at risk. Those have been shown to have a little bit of promise with influencing low birth weight. Another opportunity for intervention in the realm of environmental health is, first of all, smoking cessation efforts. So smoking, active smoking is a behavior, but when the child or fetus is exposed to it, then it's an environmental exposure. So a lot of smoking cessation efforts have been successful in pregnancy, so just continuing to do those with an environmental health perspective. Other areas or opportunities for intervention are community interventions. So examples of this might be pest management. So pests, specifically rodents, bring in a lot of disease and chemical exposure. So managing those, like especially in multi-unit housing, is a great community intervention that can be done. Also, increasing access to organically grown food to reduce exposure to pesticides and things like that. And then increasing availability of natural beauty and cleaning products, again, to limit people's exposure to endocrine disrupting chemicals or such as like phthalates. Another opportunity for translation is for policy. So specific to environmental health, I think there's some great successes and there's also still some opportunity for improvement here. So with air pollution, the EPA has air quality standards for ozone, PM, nitrous oxide, and carbon monoxide and lead. And these have been really helpful for helping cities have a target. And as I mentioned before, Denver and Austin actually have quite low levels of some of these exposures, which is great. And I think that having these standards has actually really helped a lot of cities make efforts to limit these exposures. But there's still the issue of, these EPA monitors and these standards really only apply to outdoor ambient air pollution. And we know actually that we get a lot of exposure from indoor exposures. So really educating people and helping people with their indoor exposures would be very, very beneficial. So this can include, turning on a vent hood when you're cooking to help with those cooking exposures that you might have, limiting carpeting because that traps a lot of, not only does it have chemicals in carpeting itself, but it also traps some of these chemicals. Pets obviously can be much like rodents, they can also have carry some of these allergens and things like that. Policy, so with smoking, smoke-free policies have been very beneficial for reducing people's exposure to secondhand smoke. Tobacco taxes, that's a little bit more controversial. So sometimes it's not clear whether those actually limit that exposure, but that's certainly a policy that has been tried. And then I think an area for an opportunity for the United States anyways to have stronger warning labels. So in Amsterdam, they have much stronger warning labels on their cigarettes. As you can see here, some of them are really quite graphic and they just show the health effects visually so that you kind of have to be confronted with it when you buy a pack of cigarettes. And that's something that's been shown to be really effective and it's just has not been tried here in the US. So that's a potential opportunity for policy in the United States to limit that exposure. Another really interesting area for policy is with respect to perfluoral alkyl substances. So I mentioned these earlier, these are used very commonly, or they were, to make nonstick pans, also just in a lot of like industrial cleaners and things like that. There was a very large class action lawsuit, actually a couple in the US, where communities were highly exposed because they were near these manufacturing plants. So out of this class action lawsuit, they did a very large, extensive study of the hundreds of thousands of people who were exposed, and they found that PFAS was very strongly linked to certain health outcomes such as cardiovascular problems, as well as certain types of cancer. So in response to this, there's been a voluntary phase out, which is great. It's just unfortunate that PFAS is very persistent in the environment, particularly it lives in our water, and it also stays in our bodies for quite a while. So the half-life is 2 to 5 years for these traditional chemicals, and it takes 5 half-lives for complete removal. So could take up to 25 years for your body to completely eliminate these exposures. So even though we phased it out a long time ago, it's still detectable in a lot of communities, unfortunately. And another interesting area for to think about is that there's now Gen X chemicals. So these same companies have designed these chemicals to be less environmentally persistent, which is good. They have a half-life of days instead of years, but they are showing up in the same water sources as the traditional PFAS, such as PFOA, which is one of the most common PFAS. And this really points to a very important opportunity for policy, which is to have regular testing of these chemicals in our water sources, and also just to educate people and just keep people informed about what their exposure might be and how they can limit that exposure. So that is that for translation of findings. Now I kind of want to wrap up by talking about future directions for this whole idea of fetal origins and how the nutrition and the environment can lead to or contribute to obesity. So far I've been focusing specifically on exposures during pregnancy, but I think a great way to think about this would also be to use a life course approach. So we know that fetal life is a very important window of exposure, but we know that we're exposed to a lot of things in infancy and childhood, adolescence, and so on. So it's important to really to use this life course approach so that we can think about the windows of susceptibility and whether certain time points such as pregnancy might be more important relative to others, whereas adolescence, might be in a more important window of susceptibility for other exposures or outcomes. Another benefit of the life course approach is that you think about it in terms of the accumulation of risks over your life rather than at just one single time point. So again, if you're continually exposed throughout life, you might have an increased risk for whatever the outcome might be. And then the other thing about a life course approach is that it's important to think about not only the interaction between these different exposures, but also mediation, which I touched on earlier. Another evolving approach is to think about multiple pollutant or mixture models where you're looking at different exposures altogether. But the most novel would be having kind of an exposome approach. So this is the idea that our exposures, we have an external environment, which is our lifestyle, which includes things that we eat, our sleep patterns, stress, physical activity. We also have our physical and chemical environment. This captures everything from air pollution, the climate, heat, things like that, smoking, green, even the built environment, green space that's available to us, our social environment, so how well connected we are, our neighborhood characteristics, and all that plays into our internal environment. And that influences this omics, which you may have heard of, so the transcriptomics, proteomics, and the metabolomics. And when you think about this, you're really thinking about maybe the mechanisms of why these external factors like lifestyle and your physical chemical environment, why that influences your internal environment. And all of this can contribute to obesity. But I spent today really focusing again on fetal origins of obesity. So I stayed very focused on that, looking at what in pregnancy is related to obesity and offspring. But this can be applied to many other outcomes. You can think of it in terms of neurodevelopment, cognition and academic performance, behavior, things like that. Obesity, but also other cardiometabolic outcomes, such as cardiovascular disease, diabetes, respiratory outcomes. But again, you can keep going on and think of this in terms of cancer, infectious diseases, and reproductive health. So I really think that this is pretty ambitious to think about the exposome, but with really, with improved methods, we're getting better about being able to look at multiple exposures at the same time with, for instance, one small sample of blood. Metabolomics is getting more and more efficient. And then with things like the ECHO consortium, where you have multiple cohorts coming together to increase the sample size and really pulling all those resources together to make even greater studies so that we can look at the exposome, look at these exposures together, not just one exposure at a time and one outcome at a time. So I just want to say thank you again so much for coming to my talk today. I want to thank all my collaborators and just feel like I've had a really great opportunity working with Healthy Start and ECHO. And I also want to thank the NIH for funding this research. And yeah, again, thank you so much for coming to my talk.
Well, thank you, Brianna. That was a great talk, very educational. And yeah, I loved hearing about your very last couple slides, where you suggest looking at all these different environments all together, and that just makes so much sense. So we do have some questions, and the first one, let me see real quick. It is, why would infants who are not breastfed have increased adiposity levels if exposed to secondhand smoke? And then there's a comment in parentheses. I would think they would have a greater risk for being underweight or have lower adipose levels.
That's a really great question. I should have specified that the outcome there was actually adiposity in childhood, not at birth. So that might address your question partially, that they were at an increased risk because these were postnatal adiposity markers. So as I kind of mentioned, they tend to be low birth weight, but then have an increased risk of obesity and adiposity. Another thing to think about is that, and maybe you were getting at this too, I actually didn't know if breastfeeding would be protective, because I thought maybe if the mother smoked, that the child would not only get the ambient exposure to secondhand smoke, but also the lactational exposure, because what the mom eats and consumes shows up in the breast milk. But I was pleasantly surprised to find that even if there is some potential lactational exposure, that breastfeeding overall was still protective for those children who were exposed.
Okay, great, thank you.
Thank you.
Okay, thanks. Another question here is, how much does age at which adiposity rebound occurs play a role in increasing risk for obesity? Do you think it would play a bigger role than the starting neonatal adiposity percentage?
That is a really excellent question. So I think the age of adiposity rebound is across studies. Our study actually was a little bit younger than other studies, which I'm not really sure why. Adiposity rebound tends to be kind of around 6, and in our study it was more like 5. So that was something kind of interesting to think about. I don't know which one would be more important. I think that's why there's like this interest in looking at trajectories in general, is to kind of like look at the trend in their growth, not just one or the other. So I can't really say which one I think would be more important, but I think the age at adiposity rebound could be very important, because we know that like when their peak height is, for instance, that the earlier that occurs, that's related to some certain outcomes. So that's a really great question, and I don't really have an answer about which one's more important, but great question.
All right, thank you. The next one is really, it's not a question, it's more a comment. It says, in terms of nutrition, medical doctors have to be held accountable for referring obese and overweight women to a dietitian for weight management pre-pregnancy and during pregnancy. This will assist with decreasing a woman's chance of hormonal and metabolic changes that can lead to neonatal adiposity. Many pregnancies in the US are unplanned, and therefore the more positive efforts the mother makes prior to pregnancy, the better. So that was just a comment. There was really no question with that comment.
Oh, but, yeah, just the last part of that about intervening before pregnancy, I think preconception would be the ideal time, but a lot of times those women aren't going to the doctor as much, and it's a little bit harder to catch them. And I also think pregnancy is a time when women are a little bit more receptive. We know that like women get healthier in pregnancy, so I think preconception would be ideal, but I just think it's really hard to actually do those studies in preconception. But that's a really great point.
Okay, some more questions are coming in. Okay, let me make sure that I get this right. It says, given that stressors are stressors, is there consideration given to the effects of a mother being in a stressful situation? I recall that when one gives birth to an infant that weighs more than 2 pounds, more than the previous infant, it is indicative of diabetes, naval gestational diabetes in the mother. Could maternal diabetes affect the weight of the infant?
Oh, absolutely. Gestational diabetes is very strongly related to a macrosomic, or actually both, but it's very strongly related to birth weight. So yeah, diabetes tends to be, gestational diabetes is a very important risk factor, and that's why it tends to be really closely tested for and also monitored in pregnancy. But that was, yeah, that's a good question.
Okay, thank you. And here is one more.
Okay.
Okay, again, make sure I get this right. It says, with pregnant mothers who have gestational diabetes, which is prone to higher birth weight children, but if these mothers also have a single umbilical artery, which can cause low birth rate, does that child still have a higher chance of obesity as they grow due to the diabetes, or does it tend to even out? I'm not sure if I got this right. Does that make sense, Brianna, the question?
Yes.
Okay.
What we know, I'll just talk about kind of birth weight, and then I'll talk about diabetes. So basically birth weight on, you kind of, ideally the offspring would be in the middle somewhere. We know that low birth weight is associated with increased risk of obesity, and high birth weight is associated with increased risk of obesity. So gestational weight gain, whether it contributes to low birth weight or high birth weight, not only will that child have an increased risk of obesity, they will also have an increased risk of type 2 diabetes in childhood and adolescence and adulthood. So, and that has been, interestingly, that has been studied pretty thoroughly, but there's even been sibling studies, so basically looking at siblings who were discordant for maternal gestational diabetes. So the mother was had diabetes with one child but not the other, and you find that the child who was exposed to gestational diabetes had a much higher risk of developing diabetes in childhood than the one who didn't. And so this really points again to it not just being the postnatal environment, but really pointing to the importance of the fetal environment and what they're exposed to in pregnancy.
Right. All right. I think those are all the questions that I see right now. So I have a question for you. What are some of the your future studies that you're interested in looking at in terms of this particular area of research?
So I didn't talk about this at all today, but I have been looking more and more at exposures in pregnancy and childhood on neurodevelopment. So looking at neurodevelopment in terms of, fine motor development, which is like being able to write and communicate, things like that. Also looking at the child's behavior, so aggression, autistic traits, things like that, and their actual cognition, so how well they're able to perform certain tasks, things like that. So that's a really important area of research for me. And then also really soon, it's going on right now, but I'm having cannabis measured in the mothers. So basically the mother's either active exposure to cannabis or secondhand exposure to cannabis potentially, and looking at how that relates to not only neurodevelopment, but also the child's growth, because it's possible that it could be the same situation where it's low birth weight, higher risk of obesity. We're just really not sure because there's just not a lot of research because it's been illegal for so long, but that's kind of the research I have coming up, and I'm really excited about it.
Oh, great. Yeah, that is super interesting, especially with the cannabis, because there's not that much research out there. And given the prevalence of it, yeah, that'll be super interesting.
Yeah.
But if there are no other questions, I think unless you have anything else you want to share with us, I think we can just thank you for your time and for your great presentation. Again, those of you who are watching, these slides will be archived on our website at msdcenter.org. And I hope to see all of y'all for our next webinar. Thank you. Thanks, Brianna.
Thank you so much for having me. Thank you so much. I really appreciate it.
Absolutely.